I got asked this in a Microsoft interview. Reverse the words in a string. I said easy. Split, reverse, joy. Got it right? Then the interviewer said, what about the extra spaces? I froze. I hadn't handled leading spaces, trading spaces, or multiple spaces between words. The problem told me to. I just didn't read it carefully enough. LeetCode 151, reverse words in a string. This is a medium. Let me show you why. And more importantly, how to never miss those details again. This problem has been asked in real technical interviews at Amazon, Microsoft, Meta, Apple, Bloomberg, and Adobe. 6 major companies. That's not a coincidence. This problem tests something every senior engineer needs to demonstrate: attention to detail under pressure. Stay for the pattern recognition section. I will show you the exact phrases in the problem statement that reveal the full solution. Let's get into it. Let's make the problem formal. Given a string S, reverse the order of the words. A word is defined as a sequence of non-space characters. For example, let's say input string is the sky is blue. Then our output should be blue is sky tea. Okay. Let's take second example. If your input string contains hello word containing multiple leading spaces and multiple trailing spaces, our output should be only having the words in reverse order, and output should not have any leading and trailing spaces. Only the words in the output should be separated by single space. Okay. So key constraint is, and this is what trips people up, that return string must have only a single space separating the words, no leading or trailing spaces. Let me show you what this problem actually looks like, because there are two layers to it. Take this input. The sky is blue. The sky is blue. So what do you see? There are some leading spaces, two spaces at the start, trailing spaces, two spaces at the end, multiple spaces in between words, and three spaces between the and sky. Okay. So this is the real problem, not just reversing the words. Anyone can do that. But cleaning the input and reversing the words in one clean pass. The expected output is blue. Blue is sky D. Right. No leading spaces, no trailing spaces. Exactly one space between each word. The words reversed and the mess cleaned up. Most candidates handle the reverser, they forgot the cleanup. That's why this is a medium. Now, here is how I read this problem and knew exactly what to build. Let me show you how to extract the full solution from the problem statement before writing a single line of code. I am going to highlight three phrases that tell you everything. So, phrase 1 is reverse the order of the words. Reverse the order of the words. Not reverse the characters, not reverse the string, reverse the words. That tells you the unit of operation is a word, not a character. So you need to first identify and extract words, then reverse their order. That's a two-step signal. Split into words, then reverse the collection. Phrase 2 is leading or trailing spaces. Okay. Leading or trailing spaces. And multiple spaces between two words. This tells you the input is dirty. You can't trust a simple split. You need to handle spaces at start, spaces at the end, multiple consecutive spaces. In Go, strings.Fields handles all three. It splits any white space character and ignores empty tokens. That signal to dirty input use fields not split. Phrase 3 is single space separating the words. Okay, single space separating the words. The output must be clean, exactly one space between each word. That's signal 3. Join with single space after reversing. So, what is the full solution? Solution is fields plus reverse plus join. That's the full solution. Three phrases, complete solution before writing any code. That's what interviewers are watching for. Now the key insight. There are two approaches here worth knowing. Approach 1 is built-in functions. clean readable interview shape. Okay, so let's write the approach one. Words that will be equal to fields of s is string. Okay, so the fields is basically a built-in function in Go. What it will do is it will split plus clean spaces. Then what we need to do is to the words array reverse words array. So we will be reversing in place, and then simply join with join with single space. Okay, what is it? Is single space join. Order of n time, order of n space. This is what you write first. And the approach 2 is manual 2 pointers. So this is basically our approach 1. Approach 2 is you will be using two, we can use two pointers. What interviews ask as a follow-up? Can you do it without building functions? So what we need to do in this case is reverse entire string first. Reverse en, en, entire string first. Then reverse each word individually. Then clean the spaces. They clean the spaces. So the time complexity will be order of n, or extra space will be order of 1 if strings is mutable. In Go, strings are immutable, so we still need order of n for the byte slice, but the algorithm logic is order of 1 extra space. Know the approach 1 for speed, approach 2 for follow-ups. We'll code approach 1 today. It's what most interviewers expect. Now let me write the clean Go solution. We'll start with splitting the string using the Go's built-in functions fields. Okay, so we'll take words variable, then we can use strings.Fields function and pass the string to it. Okay, so this is the API. This is the key call. Fields split by any white space, spaces, tags, or new line characters, and it automatically ignores empty tokens. So leading spaces, trailing spaces, multiple spaces all handled in one line. Okay. Now let's take two pointers, left and right pointer. Left pointer will point to the 0th location, and right pointer will point to the end of the words array. Okay. Now, what we need to do is we need to try it our reverse loop. Okay. Our termination condition will be left less than right. Till then, we simply swap words of left, words of right is equal to words of right or words of left, and then we simply move our left pointer ahead and right pointer inwards. So this is basically a reverse loop. Two pointers left at 0, right at the end of word slice, swap and move inwards until they cross. We are reversing the words slice in space in place. No extra slice needed. Finally, what we need to do is we need to simply join our words array using strings dot join. Okay, we'll pass words array and we need to join using a single space, right? So this is an entire solution. Let's execute it. Let's first call from the main reverse words. Then let's pass the output. The sky is blue. Let's check if our solution works. Okay, so the words in original strings are the sky is blue and the output string is blue is sky. Okay, p- our program is basically properly reversing the words. Let's try some other example. Maybe we use some leading spaces, hello, and where, and after some trailing spaces. Also maybe multiple in between spaces. So our output should only contain word hello, right? In this order. Nothing, no leading spaces, no trailing spaces. We need to see this, then execute. Okay. So the output is word hello, right? So all three, all the inputs, all the edge cases will be handled clean and simple. So here is how to present this in an interview. This is your interview script. I noticed two things in the problem statement. The input can have dirty spaces. The output must be clean with single space. So I use strings.Field to split and clean in one stick. Then reverse the word slice with two pointers. Then join with a single space. Time complexity is order of n. We touch every character only once. Space complexity is order of n for the word slice. If asked for order of one extra space, I would use reverse entire string, then reverse each word approach. Though in Go, strings are immutable, so we would still need a byte slice conversion. Detail observation, clean approach, follow up reading. That's the structure. Now, there are four edge cases worth mentioning. The first edge case is if input string contains single word with spaces. Okay, so if the input string is like this, then string.Fields built-in function will return a slice of words containing single word. And if we reverse this slice of word containing single word, then it will be just a single word string, which is hello. The other edge case will be if the string contains all spaces, then the string.Fields will simply return an empty slice. And if we simply reverse an empty slice, it will be an empty string. The third edge case is single word and no spaces. Okay, so the string.Fields built-in function will simply return a slice of word containing single element, and the answer should be that single word itself. And the other edge case is words with mixed spacing, a good example. Okay, so in that case our output should be example good A. So our code is handling all of these edge cases properly. So no special casing needed. Fields handle every dirty input scenario. So the complexity will be the order of time complexity will be order of n. Fields scan once. Reverse is order of w, where w is a word count. Join scans once. Total order of n. Space complexity is order of n. Words slice stores all characters. Let's close it. I failed that Microsoft interview not because I couldn't reverse words, because I didn't read the constraint about extra spaces. It was sitting right there, leading or trailing spaces, multiple spaces between words. I just didn't extract it. That's what pattern recognition is. Not memorizing solutions, reading the problem statement with enough attention to see every constraint they are testing. The engineers who clear these interviews aren't smarter, they are more careful readers. Drop your 30-second explanation in the comments below. That is the actual prep. See you in the next one. If you are preparing for coding interviews, this is the LeetCode 75 series where we solve every problem with full intuition and go code. Click the playlist on screen and continue with the next problem.